So this is your helpful hint video for FRQ 2008-6A, which is assigned today, 822. First of all, there's two things on here that I think that might be a little bit challenging to you. We know how to find the equation of a tangent line, okay? I know you guys do. You start by finding m, right? And to find your m, you take your function that they give you, right? And you take the derivative of it, and then you plug in the x value that they give you, right? And then you also need to have a y value, right? How do you find the y value? You take your original function and you plug in the same x value. So you plug the x value into the derivative, and you plug it into the original. And once you have that, then you write your equation. So you have your y minus whatever you get here. We'll call it I guess we'll call it a. So you put your y value there. Then you put whatever you got for the derivative after you plug the number in for the slope. And then you go ahead and plug in the x value and you have your equation, right? We've been doing that all along. So here's one thing that's a little bit confusing, and yet it's actually easier than what we've been doing. On this problem, they give you the function, right? So that's what you're going to use to find your y value. You just plug your x into that one. But what we've had to do is we've had to find the derivative ourselves. Okay, well, we haven't learned how to find the derivative of a natural log function yet. But the good news is that we don't need to. They've already told us what the derivative of our function is. It's right there. So to find your slope, we don't have to find the derivative. They gave it to us. So just take the derivative function and plug in your x value. And from there you can find your equation. Okay? Now, the other thing that's hard is that they're asking you to plug in a really weird looking thing. And we're plugging in a really weird looking thing into something else that's really weird. And so we kind of need to review a little bit of our rules about logarithms and natural logs here. So first of all, log is something where let's go ahead and put an A here, B here, C here. Log is it's the inverse of an exponential function. And so if log base A of B equals C, then A to the C power equals B. So let me give you guys an example here, okay? So log 2, let's say 16 equals 4. Well, if you want to write this as an exponential function instead, what you do is this is your base, this is the power, and this is the output. Okay? Up here, the 16 is the input and the 4 is the output, but down here, the 4 is the input and the 16 is the output because they're inverses of each other. So it's kind of helpful to think of logs in terms of exponential functions. Now, when you're dealing with a log that has a, let's say we had a number here like 2, and I had a 2 here, equals something, right? Well, let's put this in exponential form to figure out what that something is. We have 2 to this unknown power is equal to 2. Well, what would that unknown power be? 2 to what power equals 2? Well, the answer is 1, right? And so now we have an interesting little rule. When the base matches this, the argument is what that's called. When the base matches the argument, the answer is 1. Okay? So here's our rule. Log base A of A equals 1. All right? So hold on to that little piece of information. Let's do another one. Suppose I had this. Log base 3 of 3 to the 5th power equals something. Well, if we write this in exponential form, it's going to be this base to this unknown power equals this argument. So what's the question mark? 3 to what power is equal to 3 to the 5th? Well, surprise, it's just 5, right? And so the answer for this one is 5. So now we have another rule that's kind of the same as the last one. When the base matches the argument, the answer is just going to be the exponent, if there is one. Okay? So we have this rule as well. Log base A of A to the nth power is equal to n. All right, we're getting there. We're getting close to having enough information. So let's talk about this. What about log base e? Now, in case you guys forgot, e is not a variable. It's a number like pi. It's approximately 2.71. It's called Euler's number. Now, if you have log with a base of e, then what we do is we rewrite that as ln. All right? So now let's take a look at this, for instance. Let's say you were trying to find what is ln of e. Well, ln really just means we have a log with a base of e, and my argument is e. Well, these match, don't they? And we talked about how when those match, the answer is 1. Or how about whenever we have ln of e to the 6th? Well, ln, remember, is just log base e, and my argument is e to the 6th. We also talked about how when these match, the answer is just the exponent, which is 6. Okay? So this information here is going to be very helpful to you guys whenever you are working on this FRQ. Why? Because you're plugging a e squared into an ln. Okay? So there's your helpful hints for this video. Now that you've seen those, go ahead and try it on your own. And if you check your work by going on YouTube and watch the actual solution by YouTubing FRQ 2008 number 6 for calculus.